Okay, so we are going to go through the progress test, and I am going to go through, darn it, left my notes behind, go through it as best as I can remember about where the issues were in the progress test. Generally speaking, this first question was done quite well. There were some numerical errors here, but generally speaking, people got the idea that you use the information to model the problem to start with and then work out the dilation effect as you go along. So generally speaking, done pretty well. Many of you had -2 over x minus 1 all squared, so that should be a plus there. So a minus and then +3 at the end. Of course, that's perfectly legitimate. Some of you had a -2 on top. That's legitimate. Having the minus on the bottom, some of you had a minus on the bottom. I can't remember why they did that, but that's probably, you didn't lose any marks, but it's poor form to have a negative denominator. Have the negative on top or the negative outside the fraction. This one here, I need to stop and talk to you about. It was tricky to mark in a way because people did different things, and depending on what I decided was the mistake, I could have taken different marks off. So ultimately, what I did in the end is if you had it all correct all the way through, that's 2 marks, obviously, including the order, based upon what you wrote down. So if you wrote it in a different order to this, but if I traced it through, I would definitely get this function here. You'd get full marks. Doesn't have to follow this. But generally speaking, guys, and I know I taught differently last year for those who who followed my videos in level 3 maths last year. Basically, the best thing to do to keep it as simple as possible in terms of your brain is when you get a function with a dilation in the direction of the y-axis, in the direction of the x-axis, like this has here, like a 2x, the best thing you can do is a real quick, sorry to be zooming everywhere, is a real quick factorization out of that dilation factor, so 2 outside of, and then what you're left with is inside the brackets is the translation, and you can follow the order, the alphabetical order, dilation, reflection, translations. So as long as you have factored it out, you can follow this order like I've got here, and it will work every time. Absolutely fine. So what people did normally when they got it wrong is they would write them in the right order like I've got here, but they would say a translation by 1 unit to the left. So you can see here where they get the 1 unit to the left from, because there's a +1 there. But ultimately, and I might have to do this on the whiteboard, which is not going to be great for the video. If I followed through with a translation of 1 unit to the left, what I'm doing is I've got negative, I'll try and just verbalize it so it's okay for the video. What I'll have is minus 3 over 2x plus 4 at that stage. And when you do a translation of 1 unit to the left, the next translation would give me minus 3 over 2 outside of x plus 1. Remember, we replace the input, the old input x, with the new input, which in this case is an expression which shows a translation of 1 unit to the left. So that's what it would look like. Was it +4? That's what it would look like after the transformation, 2 outside of x plus 1, which I would then expand, and you can see it would be 2x plus 2 plus 4, and the 2x plus 2 on the denominator. So you can see that now does not match what we've got in the problem. Okay, so order does matter. Remember, you are always replacing x, or you're always replacing y. So if I'm talking about a translation of 4 units up, I know it looks like that you're just adding 4 to it. But what you're doing is you're going y is equal to y plus 4. That's what a translation of 4 units looks like. It just so happens that the old y was minus 3 over 2x. So that would become minus 3 over 2x plus 4. That's the old y. Okay, that's how to think about it. I'm replacing y with a new expression, and then I can substitute in. Okay, so that'll come clear in another problem as we go along. So that's that one. Questions? So I could have said a translation by 1 unit is in the wrong order, because if you'd done it up here before you dilated by a factor of a half, that would be correct. So you can translate by 1, but you'd have to do it before you dilated. Okay, so if you had the translation before this dilation, I could have given you full marks. But either way, I could either lose half a mark for the wrong order or lose half a mark for being in the wrong translation. I tended to err towards the end of just erring on the side of just saying, well, you've got the translation wrong. But that's what I did on the board. Okay, next one. Generally speaking, done pretty well. I felt like it was one of those things you either knew or you didn't. And what I just wanted to point out here, this is how to tackle it really. You need to remember that the inverse of a function simply swaps the x and y coordinates over. That's all it does. Okay? I know there's more complicated stuff we can do, like restricting domains and all that kind of stuff to make the inverse work, but pretty well much. If you've just got a picture of the function like this, you look at the points you can see and you swappity them. That's basically it. Okay, so this point here, that point there, I'm just trying to draw it up, but it won't let me. So that point there is 10, 13. So in the inverse, it goes to 13, 10. This one is 5, 13. So it becomes 13, 5. This one is 2, 7, so it becomes 7, 2. This is a turning point here. This turning point here, which is -1, -2, becomes -2, -1. So once you've got your dots in, and 7, 4, -4 here. So once you've got your dots in, it's dot to dot, and you're trying to make basically an image, a mirror image of this through here. And that's basically it. Okay. Some people got confused, I think, because they didn't see that it translated 1 across for some reason. I think they saw this is the y-axis because that's where the numbers were. So that threw people off a bit. Question 4. Oh, questions? Okay. Question 4. You know what? It was all right. These are the steps you had to take. First of all, you had to do a sums. You didn't have to, but it was the most clear way of doing it would be to have drawn a domain range box like this. I do mine like this. You could put F and G up here and D and R down here. It doesn't matter. But some sort of domain range box here, stating all the domains and ranges. And then you got 1 mark for basically saying something along the lines of the domain, what was it, G of f of x? The domain of f, the range of f is not a subset, does not fit in is okay. The range of f is not a subset of the domain of G. I just gave full marks for that. What I did here in my solution, like it didn't matter if you didn't write this at all really, but what I said here is I showed that there was a number in the range. So 3 is a member of -1 to infinity, but it is not a member of the domain of G. So therefore, G of f of x is not defined. So that's how you go about it. Number 1, set up your domains and ranges for f and G. And number 2, show that the range of f does not match or is not a subset of the domain of G. Done. Alex, if you're not going to do your own work, don't disturb others, please. Oh, I've kept it on video too. That's good. Questions? Yep. Oh, I didn't actually talk about that, did I? So if we look at f of x, now you could draw a little picture if you're not too sure. So if you drew a graph of that, this is going to be dodgy. If I drew a graph of that, especially if it's not going to write. Is it right from here? No, it's not coming up. Something dodgy's going on. Can't write. Okay. So if I drew a graph of that, the graph of f of x would be just a parabola, right? And when you look at the domain of f of x, you could basically put in any possible value for x, it'll output something. So the domain, which is all the possible x values, is going to be all real numbers. The output, however, the parabola is going to be like this. I need some scribble paper. The output is going to be no, I can't anyway. The output is going to be a parabola which is translated down by 1 unit. So if you think of the picture, and I didn't draw the pictures, but you could draw them, it's going to look like a parabola which is in the middle, but its turning point is down at 0, -1. Okay? That's what it looks like. So if you look at that, then you'll see that -1, any value below -1 will not be hit in the function. Okay, so if I go to -2, -3, -4, -1.5, this function will not produce that value. Okay, so the smallest value it can produce is -1. If I put x equals to 0 here, then I'd have 0 squared -1, which would give me -1. So -1 is the smallest value, and then anything above that would be produced by the function. But there's no number I can put in for x that'll give me -2, e.g. Does that make sense? Similarly for this one, x could be any possible number in the world. I can put any number into this function, it will give me an output, except for 3. Because if I make x equal to 3, then the denominator is equal to 0, which would give me a does not exist kind of situation. So the domain would be all real numbers, that's what that means, except for anything I put in this set here, which in this case is just a single value 3. Everything else is fair game. Everything else will give me a number of some description. Yep. The range of G, which is not relevant to this whole question, but nevertheless, the range of G is going to be any possible number as well, positive, negative, except for 0, because 1 divided by what equals 0? There is no number that I can divide 1 by and get 0. And so 0 is an exception to the range. Does that make more sense? A little bit. Okay, I didn't draw the graphs. You could draw the graphs if that helps you make sense of what the domain and range could be. But these ones are fairly basic graphs which you found on your information sheet. So you could look at your information sheet to remind yourself of the shape, where values exist and don't exist, and you could go from there as well. You could also do it algebraically, like I just said a second ago. Okay, so in terms of notation, I was pretty... I accepted more than maybe I should have. There was some... Unless you were giving really dodgy notation, I kind of accepted it. Like some people, for example, put here, x does not equal 3. I accepted it, although it's not a set. X does not equal 3 is not a set. If you wrote r, comma, x does not equal 3, that would be fine as well. You can see from the boxes here, I just chose the notation which fitted into the box neatly. So -1 to infinity was a little bit easier to write than r, comma, y greater than or equal to -1. So I just wrote interval notation as well. You could do everything by interval notation if you wanted to. So everything by interval notation, everything by set notation, all of those things are okay. Just you've got to have some sort of set notation in there, though. You can't just put x not equal to 3 or whatever, or all x or something like that. All right, any more questions? Okay, part B. Define f asterisk, or f star, I think I'll just say, or that's technically an asterisk, such that g of f star of x exists and hence find g of f star of x. Okay. So, we did do these in class. F star basically means the function f, the same rule, but a different domain. That's the only difference between f and f star. It's a different restricted domain. So how do you work out the restricted domain so that g of f of x exists? Well, we know why it doesn't exist. It doesn't exist because it's not a subset. So you've got to make the domain of f of x the right values so that it outputs something that works for g of x. Okay? So the only value that g of x can't take on is 3. Everything else is fine. So the only value that g of x can't take on is 3. So what you do is you take the rule for f of x, which is x squared minus 1, set it equal to the boundary. In this case, the boundary is a value it can't be. So the boundary is 3. You set it equal to that value and solve for that value, solve for x. And this will tell me the x values. 1 second, then I'll take a question. This will give me the x values that would produce 3 from f of x. Okay? So in other words, if I put 2 in, 2 squared minus 1 is 3. If I put negative 2 in, negative 2 squared minus 1 is 3. And 3 is the one value I can't output from f because then g will fall over. So my new restricted domain is all real values just like it used to be, but I can't include plus or minus 2. So that's why I've got, with the exception of open set bracket, minus 2, comma 2, close bracket. So all real values except for these two. And that will produce a range of minus 1 to infinity, because that's what the old range was, except for 3, because we've excluded minus 2 and 2. Everything else is fair game. Everything else will produce a number that will fit inside the new, will fit inside of G, so it's absolutely fine. Tian. Good question. Again, for some reason, it's not. I'm going to stop the video in a second and start a new video where I can do some writing and stuff because it's bad for the video. But you can certainly do this notation. I'm going to do a bit of a mix and match. So let's just say it can't take on the values from minus 1 to 1. Not in this situation. I'm just saying, for example, you could certainly do all real values except for minus 1 to 1 in interval notation. That's a reasonable notation as well. Yeah? Oh, sorry, if it was that. Sorry, if this was the domain of G, is that what you're kind of saying? Gotcha. So if the domain of G, so you're doing G of f of x, and the domain of G happens to be, let's just say, between minus 1 and 1 to something like that. And you've got f of x, which has some sort of rule to it. And you need to restrict f of x so that it only produces values between minus 1 and 1. Have I got it right? That's what you're sort of asking? Yeah, cool. Really good. Let's just make sure it's x. Let's use x squared minus 1 as well. Okay, so what you will do in this case is you've got new boundaries. Instead of being the boundary of 3 doesn't exist, you've now got a boundary of it has to be between minus 1 and 1. So you would go x squared minus 1 equals minus 1, the left-hand boundary. Solve for x. And this will be the new boundary of f. Do the same thing for the other boundary. This is where I'm going to get myself into trouble, I suspect. Oh, no, I won't. That's all right. X squared minus 1 is equal to 1. Solve for x. X squared equals 2. X equals root 2. And so the f star domain is now going to be from 0 to the square root of 2. Yep. So in the case you had in the test, there was just one value that didn't work, so we had to exclude it. In the case of, like, if you've got a boundary like a domain for G that's restricted to, say, minus 1 to 1, you put in both boundary values and know that that's going to be the boundary for f as well. Make sense? Yeah, cool. Thanks, Tian. That was a good question. Okay, guys. Nextly, that was worth 2 marks, as you can see. So plus or minus 2. So working out that the new conditions, I suppose. That's probably a nice way of saying rather than boundary. This is the condition for the new f star. 1 mark for that. 1 mark for writing the new domain in. I've put the new range in, but you didn't have to do that. That's fine. And then 1 mark for a pretty straightforward composition function working that out. So g of f star of x is equal to g of x squared minus 1. So replace the x squared minus the x with the x squared. So replace the x in 3 minus x with x squared minus 1, and then solve. A lot of people didn't put brackets around the x squared minus 1, So they ended up with 3 minus x squared minus 1, which gave them 2 minus x squared. But as you can see here, 3 minus 1 is 3 plus 1, which is where the 4 in the 4 minus x squared comes. So again, just a reminder, I'm trying not to go back to the square one with teaching you things, but just a reminder, what this means is that f of x is the new input to g. If g is 1 over 3 minus x, if that's what it was, then you're taking the old input x, and instead of replacing it with a number like g of 2 or g of 7, you're replacing it with an expression. The expression happens to be x squared minus 1. So out goes x, in goes x squared minus 1, and then that's the rest of the problem as it is. P.S. Have a look at the new form of this function. This composite function, sorry. The composite function is 1 over 4 minus x squared. That is like a hyperbolic function as well. It's not quite because it's got an x squared down there, so there's a bit of difference. But looking at that, 1 over 4 minus x squared, what values of x, ignore all this, what values of x would this produce a result that doesn't work? 2 and minus 2. Yep, negative 2. Yeah, so the resultant function agrees with what you did over here. Okay, so keep that in mind. You still have to do this work because the resultant function may not always give you the restrictions that you require, but the restrictions that you worked out should certainly work for the new composite function. So you can look at the composite function and have a bit of a check to say, yeah, they work out. Okay, that's it. I'm going to stop the video here. You can have a bit of a stand-up break if you want to, but just for 30 seconds while I switch technology over, and that'll give you a brain break as well so that you can keep on concentrating.